Hello, welcome to Harper Carroll AI. I am Harper and we are doing a Q&A today. So this is something that I do about every 2 weeks and I just answer your questions. And if you don't know me, I'm Harper. I have 2 degrees, so an undergraduate and graduate bachelor's and master's in science, in engineering, in computer science, focusing in artificial intelligence from Stanford University. And then I was at Meta for 4 years working on building machine learning systems there, while simultaneously getting my master's at Stanford. And then I left and I was founding engineer at a startup. And then I became head of AI ML at a company that was acquired by NVIDIA. So at that company, the startup, ultimately that was acquired by NVIDIA. While I was there, I started teaching AI on X. I was doing these fine-tuning guides and those blew up really fast. And then I started on Instagram and I was teaching for a more broad audience. So on X, it was, coding guides for fine-tuning models, which is when you actually go in and change the parameters of the model. But then on Instagram was more broad kind of AI inner workings knowledge. And yeah, I've been doing that ever since. And it's been about 1.5 years now. So if you're new here, welcome. And let's do this Q&A. So let's jump into the first question. How in the world can I know if a news-looking video is ever real? This is interesting. This is a really good question because media is going to change. So as deepfakes get better and better, we will ultimately not be able to discern them from real videos. And so I actually have a video on this, so I'll link it here. Basically, deepfakes keep getting better just inherently. And with any kind of adversarial situation, and we talked about this actually in the last Q&A, any features, so for example, with like spam bot detection, any features that, for example, Meta might use to say, oh, that's a bot. Like we noticed that a bot tends to post 10 posts in 5 seconds. And then they'll say like, oh, and then we'll just wipe out all accounts that post 10 posts in 5 seconds. But then that feature that bot was using will no longer be a feature that they will use. And so Meta can't use that as a discernible feature. And in the same way, like these AI models, they're actually, that kind of adversarial relationship is actually built into how these models work. They're called generative adversarial networks. And there is a discriminator and a generator. And that's literally how deepfakes are made. It's like there's a model that creates a video. So that's the generator. And then the discriminator is saying like, is that a real video or is that a fake video? And then they just like fight. And then the generator gets better at generating and the discriminator gets better at discerning whether the video is, generated or not. And that's how these models get better and better. And so, yeah, so with deepfakes, it's like anything, like even a hand, for example. Like I think one of the things about 1 year ago was everyone would just look at the hands, right, for generated images. They would say, okay, you can tell if a photo is AI generated because of the hands. Ultimately, and I think most of that has been resolved by now, and ultimately it would have been resolved, again, because these features that we use to discern whether something is AI generated or not are all going to be resolved. And so ultimately, what we're looking at is a complete shift in how we view media and, our trust in news and sources in media. And I actually made a video on this maybe half a year ago, and it was my first viral video on LinkedIn. It got like millions and millions of views. And it was talking about this concept of deepfakes changing media, because what we will have to do is we won't be able to trust any video. So again, this question is, how in the world can I know if a news-looking video is ever real? You can't. You can. The only way to really know is that it's posted by the source, the person, the subject of the video, which will be, challenging. So if you see a video of a politician, you can't really assume it's real unless it's posted by the politician. If it's of them talking, for example, because it could be AI generated. But then you wonder, what if it's a video of them doing something great and it's just like fake, and you just don't know. And so things are really going to change here. There will be a new idea of media, like where we won't really be able to trust it. But what I said in this video and what I'll say here again is that I actually see that as a positive, because media, there have been misrepresentations in media for as long as media has existed. So there's this concept called Gell-Mann amnesia, where if you read an article about something you're familiar with, you'll be like, wait, this is so inaccurate. There's so many like factual issues here. This is not true. And then you'll move on to a topic that you're not familiar with, and you'll just assume everything is correct. Like if you're reading a newspaper and you read one article and you know about it and you're like flabbergasted that it could be so wrong, and then you just move to the next article in the newspaper and you assume everything is correct. And so that's Gell-Mellon amnesia. And so I think healthy skepticism of media has needed to exist for a long time. There are various methodologies for having this kind of identification. And also, I know Sam Altman is working on something called World, which is like retina scanning for the internet. And this is kind of like tangentially related, but World basically is a way to prevent the dead internet theory. It's the idea that AI will flood the internet and basically everything will just be AI generated. And we'll have AI bots talking to each other and AI generated videos and just like, it'll just be slop everywhere, which is a really sad future. And I think the concept of World, which is like having people have to, identify themselves on the internet, is kind of a long time coming, has been a long time coming. And I'm excited that Sam is working on it. And yeah, that actually, the reason I'm pausing here is because I knew it reminded me of something. And it's reminding me of YouTube not monetizing AI generated content. Amazing. I will say I've been on YouTube recently and there has been so much AI generated content recommended for me. And it's been kind of a bummer. And I just think that not being able to monetize it is so brilliant. It's so brilliant. And I'm so excited that YouTube is doing that because this kind of like low effort AI slop. A lot of it's slop. I mean, you can use AI to not make slop 100%. But if it really is just like churning out videos to get views and it's like regretted time, then it's just not worth it. Very cool. Best AI for everyday use. There are a lot of different AIs that you can use. I like using Claude. Claude is probably my favorite one. It's by Anthropic. It's just a great model. It has a great personality. I like its vibes. The issue with Claude and with a lot of these language models, and we have talked about this in prior Q&As, is that these models hallucinate. The core of AI models, of large language models in particular, so these text generation models, they can make things up for a variety of reasons. They can make things up. One of them being the fact that they're just probability based. Like they generate tokens or fragments of words based on probabilities, and it can kind of just make things up. It doesn't actually have like a storage of knowledge in its brain. It's learned patterns in text and it outputs text according to those patterns, but it doesn't inherently have access to actual facts or databases or what have you. One of the issues with Claude is just out of the box, it doesn't have access to external data like the web. So I think they have a beta version access to the web. It wasn't good last time I looked. There are models that do use the web and they cross-check their output with the web. So for example, Perplexity will do that. Perplexity is a really cool resource. I like Perplexity a lot. I'm not associated with them yet. I would. They're cool, but I'm not associated with them. They basically host a bunch of models on their site, open source models. So models like DeepSeek and Meta's Llama, you can choose which model you want to run. And they also have access to some closed source models. So I think there was some Claude versions there and I think a Grok version as well. And basically you can choose your model, but then it also hooks up to the web and it'll provide sources for you. So it helps reduce hallucinations. So if you're looking at anything that is recent, like if you want to learn about something that is news, you'll want to use one of these models that searches the web because the large language models have been trained up to a date. And so, well, one, you want the factual knowledge, but two, it's like literally won't even have it in its pattern recognition because it wouldn't have been trained on it if it's like recent news or something like that. So for every day, I do like to use Claude. I like to use Claude for things like, for example, like someone asked best AI for relationship advice. I think Claude is really good for that. I like its personality. It, like most language models, has been trained on the internet, which includes, lots of resources on psychology and, relationship dynamics and optimal communication strategies and things like that, and attachment styles, etc. So that knowledge combined with the fact that I just like its personality, I think it's cute and sweet. That's why I like to use Claude. And it's also good at writing. It's just the one that I use for every day. But if I need access to the web and I need to make sure that the data is accurate, or I want to find a recent news story on something, I use something like Perplexity. I hear ChatGPT does it very well as well. There's also for like research papers and things like that, I think Scite AI, SCITE.ai does like research papers. So if you're trying to find research on a certain topic, that will help retrieve it for you. Also you.com, you.com also has some good ones. And so again, these are models that provide sources. So if you need sources, if you need to reduce hallucinations, you need to be aware that some models like Claude are good for some things, but not good for others. And so you need to be really cautious of that. So best AI for health advice under this, I mean, again, things like Claude, ChatGPT. I've heard the ChatGPT paid version, like the $200 a month version, is exceptional for all different types of things. My mom actually was with my grandma, and there was like an issue with the plumbing in the house, and she called the plumber, and he was there for 6 hours and couldn't figure it out. And my mom was just devastated, and they had no cold water, and my grandma had it was just like a whole thing. They had no hot water, and it was just a whole thing. And my dad, who was using the paid ChatGPT version, asked it what was going on, sent it some photos, and it said instantly what the issue was. And it was a very simple fix. And my mom fixed it herself, like in minutes. And I've heard that it's really good for health topics as well. I know people who, my friend, his wife just had a baby, and ChatGPT predicted the birth time, like from the very beginning, like 8 hours prior, based on the heart rate and like all the other stats that were showing up on the screen. And, the husband was just taking photos and putting it in ChatGPT, and it was accurate, I think, to the minute. And he said it was super helpful. So yeah, so for health advice, a lot of these just normal models are useful. I think there are some, I know ADA Health, I think it's called Ada Health. That is a model that is specifically for health topics. So you could take a look at that one. But yeah, AI for health advice. Oh, and I was just sharing this too. My little puppy who's here. Oh, hi. My little puppy the other day hurt her back, and I woke up. What happened was we came home, and she's very sprightly. And we came home and we were going up the stairs, and she just stopped halfway up the stairs and looked at me, and she's never done that before. She didn't want to climb the stairs anymore. And then the next morning, I just figured maybe she was tired or something. I don't know. So the next morning, she was like hiding and shivering under the bed and wouldn't get out. And she doesn't do that at all. Normally she's so excited to get up and going. And so I asked AI about it. Oh, and she also didn't want to walk down the stairs when we were going to the bathroom. She stopped. Well, when I wasn't going outside. But AI predicted that it was a back injury, right away, instantly. And I was thinking, no, maybe she ate something bad because she was with my neighbors. But then I took her to the vet, as it suggested. I took her to the vet that morning, and they touched her back, and they said that was the one area that she had pain. And so it was a pain issue, and so a back issue. And so that was really cool that it predicted it immediately, right away. So she's just cuddling. She's very cute. Hopefully she'll get up at some point during this. Okay. If a large language model remembers your chat history and uses that to influence itself, does that consume tokens? This is a very specific question, but maybe it'll help you guys have a better understanding of how these large language models work. And also, just as a reminder, I feel like one of the things I'm most excited about with these Q&As is that I think it'll help people have a better intuition for how AI models work. So hopefully this helps you achieve that. So if a large language model remembers your chat history and uses that to influence itself, does that consume tokens? Yes. So what large language models can do is they have a context window. So it's like a length of data or tokens. And remember, tokens are just fragments of words. So if you're talking to a large language model and you have a long chat history with it, so say you have a single thread with, ChatGPT, and you have a long conversation, you'll notice it takes a long time for it to come back to you, much longer than if it were a quick chat. And that's because it is consuming all those tokens. It is receiving the full chat history every single time you send your question to it. So every token that it predicts, it is looking at all of the prior tokens and the relationship between all of those tokens. And so those tokens include whatever's in the context, which could be, the chat history. Or for example, in ChatGPT, it has this memories feature where if you tell it something that it deems is relevant to you as a user, it'll store it in its little memories box. And you can go to your settings. I made a video on that too. I'll link it here, but you can go and look at what your memories are. And you'll notice they're very pithy statements. Typically they're not paragraphs. They try to keep them very concise and exactly just what it needs. But those are also passed in to the model when it's generating responses. So for example, if I tell an AI model that I am an AI educator and I live in, Los Angeles, and I have a dog named Evie, and it deems those as worthy of storing in its memory of me, then every time I start a new chat, I'm assuming it doesn't include in every single prompt I send to it, like over and over again, but it'll probably put it at the top of the context, or like hidden. It'll hide it at the top of my chat with the model so that the model will consider that as it's answering me. And so two separate people using ChatGPT with their memories turned on could get very different results in terms of like the answer of a question that they ask if it's the same. So for example, like if I ask ChatGPT a question about AI, and if another person asks ChatGPT a question about AI, because AI knows I'm an AI educator and have, degrees in it, it might answer it much more in-depth way, much more technical way than it might answer another person who either doesn't have that statement said about them in their memories, or has a statement that says they're a beginner, or like that they're like 10 years old or something. We've talked about AI for kids, and I think it's a really cool resource for children to learn. And obviously it needs to be monitored. And as I said in my last video about this, I absolutely do not think it replaces human to human interaction at all. But I think it's a really great learning resource for kids who have free time and want to learn about something cool. So to go really in depth, So yeah, I hope that answers your question. Yes, the context in a model's brain does indeed consume tokens. Those tokens are like the text that is in the model's brain. So whether that's your chat history, whether that's the memories, whether that's part of RAG, which we'll talk about, where it like puts it into the prompt, whatever your prompt is, that is transformed into tokens, which are then processed by the model in order to produce an output. So all that text is considered by the model to produce an output. Okay, hallucination from a math perspective. This is interesting. So we talked about hallucination, and someone asked me this question in my last video, like, why is it when I ask a large language model math questions, it does so poorly? And, it'll like make up random numbers. Like, for example, if I have a case ID, it'll make up like random case IDs that aren't real for, legal matters and things like that. Why does that happen? This is a great demonstration of why hallucination happens. So the reason that large language models tend to need to be augmented, either trained specifically on math problems or augmented with like a calculator, is because exactly what I was talking about with them being probability-based machines. So when a large language model is trained on the internet, it has an enormous amount of data that it looks at. It learns the relationships between words on massive amounts of internet data. With math, first of all, there isn't as much training data. There's just enormous amounts of text data on the internet. And also one thing with text data is that you can create even more data from it. So if I have the sentence, hi, my name is Harper, and I want to use that sentence to train a model, I could cut it up into every single piece of that. So I could say I could teach the model to predict my after getting high. I could teach the model after getting the token high. And that could be a thing where it's like the input is high, the output is that it should predict my. Then I could also cut it into, given hi my, it should output name. And then I could also cut that into hi my name, and then it should output is. And then hi my name is, and then it should output Harper. And so that's I don't remember, but that's 5 training examples just from that sentence. So if you're looking at the entire internet, it's enormous how much training data you can get from that. And that's why these models are just exceptional, because they really do understand the relationships between words in a really kind of nuanced and complex way. With math, there isn't that kind of first off, you can't really cut it into that kind of probability, right? It doesn't have a concept of multiplying things. It doesn't really know how that works. It's predicting okay, if I get 5 and then I get a time symbol and then I get 3, then the output should be 15. Okay, maybe that's one example. Maybe that's one training example. But then imagine, cutting that up. It's okay, it gets 5. Should it predict an X, like a time symbol? Should it predict a division? Is 5 times 3 more likely than 5 times 2? The probabilities of math problems doesn't hold up here. It's okay, 1 plus 1, it should be able to guess 2, because that's such a common math problem that you see on the internet. But, is it gonna see the example 653.4 times 896.72 and know how to solve that. Like it doesn't, again, it's outputting based on patterns it's seen before. And with numbers, it's like that doesn't really hold up. What math equation is more likely than another? And is that really what we're solving for here? No, it's like math is a set of rules. It's not really probability based. The output isn't probability based. And so with these case numbers, it's like, okay, so the model learns that, so say it receives, 10,000 examples of legal documents that all have different case numbers. Okay, it'll probably get the length of the case number right. If they all have the case number, it'll predict, okay, I should output, say they're all 10 digits. Okay, it'll output something that's 10 digits. But because there's so many different combinations of digits, for any given digit in those 10 slots, it's just outputting a probability. It's just choosing a digit from a probability. So it's not going to choose like J if it's always, numeric, not alphanumeric. It's going to know the probability of J is like 0. But the probability of any token between 1 and 9, 0 and 9, probably pretty equal. And so it's going to make up, because it's a probability sampling machine, for every digit, it's going to just sample from like 0 to 9, But again, it won't like choose a random token like high. Again, tokens are fragments of words, so it's possible that high is its own token. But again, yeah, it's going to know it's a number, but it's not really going to know which number it is. So, and that goes back to the fact that they don't actually have access to specific data sets. For example, these legal cases that it was trained on. It doesn't actually, once it's been trained on it, it doesn't have access to it anymore. It just uses it to learn how words relate to each other, but it doesn't have like photographic memory, in the same way we don't. Like you might look at a bunch of case numbers and know, yeah, I mean, they have 10 digits and they're always digits. But could you cite a random case number of a like legal document that you read? Probably not, unless it was a very special document that you looked at a lot of times, So I hope that explains why hallucinations tend to really happen with math problems and why large language models don't do well on math, because it's math. It's not language. It's like math is a set of rules, and AI large language models learn from examples. And so you would have to have like infinitely many examples for every single possible math problem you could ever do for it to do well. So I hope that helps. And if it doesn't, if I could explain it better, this might be worth doing a whole video on. So fantastic question. Thank you for asking it. Let me know in the comments if that clarifies it for you. Okay, RAG. Let's get into RAG now. Like, how do we fix hallucinations? RAG, Retrieval Augmented Generation, is one way of fixing it. So basically what Retrieval Augmented Generation does is you have this like external database system that has the data that you want the model to reference. It is transformed into embeddings and kind of split up, and then each of those little pieces is transformed into a numerical representation that captures the meaning of that text. So like one of the really beautiful things that AI does, and one of the things that I learned about as before I even knew what AI was, it's like math can put numbers to social situations or to things that don't have numbers. For example, words. Like it can capture the meaning of a word in numbers, which is amazing. And that's what it does with these embeddings. It's like you can take the word king and transform it into embedding, an embedding, which is just a string of numbers. It's actually like a vector, which is kind of looks like a string, just a series of numbers. And then if you were to kind of reduce it down to 2 dimensions and put it on a plot, and you also put queen there, you might have king and queen close together. So this number representation on this high dimensional space puts similar words, it captures the meaning, it puts similar words together. And something that's really cool about that is like, what's an example? It's like boy minus girl is equal to king minus queen or something like that. And like you can actually do math on the words in a way that's like intuitively makes sense to you, which is really cool. So like, yeah, like the vector of boy minus the vector of girl has some area between it. And then the vector of king minus the vector of queen, it might be equal to that or very close to it, which is super cool. Like you see those kinds of relationships and behaviors happen with these word embeddings, which is super cool. But anyway, so, okay, a little off topic, but what RAG does is it has this database of embeddings, and then it transforms your question into the large language model into those embeddings, and then it transforms your question that you have typed into the large language model into an embedding, as well, which captures the similarly semantic meaning of what you just asked it. And then it searches through the database of knowledge that you provided it and finds the most likely embedding. So again, these are numbers. So it can actually find what's the most similar number here. And usually it's using something like cosine similarity, which is just a mathematical equation to find how similar two vectors are. So it'll take your input, it'll look at the entire database of embeddings and match your input embedding to maybe the 5 most similar database embeddings. Or it's up to you how you implement it, like how many you'll retrieve. But then those are added to the prompt, hidden behind the scenes. It grabs that extra data, puts it in your prompt. So if you asked it about a specific legal case, given the title, it would take that, transform it into an embedding. So that title would be in an embedding. And then that title would also exist in your database as well. And so it would actually find a match for the embedding. It would grab that document, put it into the prompt. So the model would receive, if you asked a question about, as I said, that legal case, maybe it's what was the plaintiff's name in, case 1642, something. And then it was the name of it. And then it would grab, so it would have the question and it would have the full legal case. And then it would be able to answer questions. And it would transform that whole new augmented prompt, which contains your question and the data it just pulled from the database. And then it would give you an output. So it has this behind the scenes prompt augmentation going on. And so typically, if you are working with a large language model that searches the web, what it'll do is it will kind of similarly take your input, search the web for similar articles, what you've asked it, and then it will throw those into the context of the model. So it'll maybe take the top 5 results, maybe on Google, and then append that to the prompt. And so it's what we were talking about, if an LLM remembers your chat history, does that consume tokens? So yes, it does consume tokens. And that is the full context. It takes your input question, it takes what it just retrieved from the database or from the web, and then all of that is thrown into the large language model. And since it's so recent, it now, since this data is fresh in its mind, it's able to answer questions accurately. So I hope that is clear. I hope that makes sense. That's how RAG works. And it's a way to mitigate hallucinations because the data is right there. It is referencing the data right there because you've grabbed it from the database and put it in your prompt behind the scenes. What's next? Thoughts on prompt engineering. So this one is interesting. I guess I have a few thoughts. There was a craze last year. Everyone thought prompt engineering was going to be a new job, which I think I didn't think it would be because as these models are developing and changing, what prompts worked before wouldn't necessarily carry over to, models as they adapt and as the training data changes, etc. So there are some general skills that I think are useful to know when you are prompting. One is I've seen ones that say start broad and then kind of zoom in. Someone said something that I found very interesting recently. It's AI doesn't hallucinate when you know about the topic, but when you don't, it hallucinates. So it's it seems like it's right all the time because it's the opposite of Gell-Mann amnesia, maybe, where it's if you're an expert and you use it, you're oh, this works really well. And then when you use it not as an expert, you're assuming that it works well because it worked well on the thing that you were an expert on, but it's actually probably lying to you. And I was thinking about why does that happen? And my guess is that there's probably a few reasons why. One of them is that for newbies, you're probably using really broad terms. And when you're an expert in something, you might use a term that is much more, nuanced, or maybe not nuanced. What's the word I'm looking for? Jargon. It's a very specific term that only the really experts know. And so what prompts really do is they kind of zoom into the part of the model's brain that is relevant to what you're talking about. And it kind of looks at the probability distribution changes. So, for example, we talk about this example a lot, Cat in the Hat, it'll zoom into a portion of the brain that talks about Dr. Seuss and, all the other different Dr. Seuss books. If you say Cat in the Bathtub, that's a totally different part of the brain that it's in. And so the probability distribution of next tokens is drastically different, right? So if you say Cat in the Hat, the probability of saying Dr. Seuss in the next 10 words is very high. But if you say cat in the bathtub, the probability of saying Dr. Seuss in the next 10 words is very low, right? And so if you are an expert using an AI model, you might use jargon. So it will then take that word and zoom in to a portion of its brain that recognizes that word, and everything around it is expert knowledge. And so it will give back to you, it's like zoomed in, right, to this part of the brain that encapsulates expert knowledge. But if you're using a broad term, one, it might be too zoomed out that the probability distributions of the next words might be kind of spread out. And so it, as we've said before, it might like choose the wrong word and then just kind of go down that path. Kind of like how we said, if you wanted it to go down cat in the hat, but instead it went down just probabilistically, it just happened to go down cat in the bathtub, just based on the fact that it chose a low probability event, then it would just run with that and go down this like fake route. And so if you start super high level, it is more likely to kind of go down a random route than if you were to zoom in on a topic of expertise where it's like, okay, now, like, you see what I'm saying? It's like much more narrow versus much more broad in its brain, into where it's zoomed into in its brain. And I think another thing is like the training data. If you are asking it a question that is kind of framed like a noob, it might look into its brain, and I mean, it's just trained on the web. So it might give you an answer from another noob, or like, you know, it might give you like a Reddit answer, or it might give you just something wrong, you know, because it, again, is not zoomed in into this like expert domain. And so I hope that makes sense. That's kind of my view on prompt engineering. To go back to that, is that if you're using an AI model and, you know, don't know about a certain topic, maybe try to give it certain keywords that help it really zoom into expert knowledge in its brain, like jargon. Okay, privacy. This is a big one. When you are using a model online, you mostly should assume that your data is being consumed and saved by the person who is hosting the model. If you are running a model on your own computers, which you will know if you do that because it takes time to set up, and if you don't know if you have a model running on your own laptop, you probably don't. But if, you know, they are making it easier than ever to run large language models on your own laptop using things like Ollama. If you are running it through the Ollama like guide on your terminal on your laptop after you downloaded a model, it is not being sent to Ollama or anywhere else. But if you are using a model online, you should assume that your data is being stored. There are some services that claim to not store your data, like Grok, like Nebius. Great. I guess they don't. But if it's really sacred data to you, you know, just use discretion. This is a pretty big topic. Please leave your questions about privacy in the comments below, and we can continue to have this discussion. But I want to know specifically like what you want to learn about with regards to privacy. Difference between NLP traditional models and LLM architecture. So NLP, natural language processing, is a broad term that encompasses any kind of analysis of text. So large language models like ChatGPT, text generation models, those are a form of NLP. NLP, again, it's like the AI of text analysis. So there could be some forms of NLP that are analyzing text for sentiment. So instead of generating text like a large language model, it is taking in text and saying, you know, is this block of text positive or negative? You know, so it's classifying it. It's saying positive, negative, neutral. It's not generating new text. It's just analyzing it. There's also, you know, forms of NLP that are analyzing text for, you know, finding the subject and the verbs and creating graphs from them. You know, if I say I'm Harper and my dad is Chris and my sisters are Jackie and Sky and my mom is Leah and my dog is Evie, then it might take that in and parse that text and create a graph where it says Harper and there's an edge from Harper to Sky. There's an edge and that edge says sister, and Sky is her own entity. It like might create a graph from it where we have Harper, we have Sky, we have Chris, we have Jackie, we have Leah, we have Evie, and then there's edges between us. And those edge represents the relationship. Like there's a little name on the edge. I'll put a little graph here for you and you can take a look at what I mean. But that's some kind of NLP. That's analyzing text and doing something with it. In this case, it's creating a graph. It might take in text and put it into a structured format into a database. So, you know, any kind of working with text. Large language models are text generation models that use the transformer architecture, which is a type of neural network. And we talk about that in the 10 Days of AI Basics series. We go through what neural networks are, how they work, what the layers are, what neurons are. So we go through all of that. But NLP is a broader bucket of AI, which includes large language models because it's text analysis. I'll also say there are text generation models that don't use transformers. They tend to be older and outdated. But for example, Siri, my guess is that Siri was a rule-based system where it would take in text. It was a text generation machine model with some agentic capabilities. It would know when to search the web or look at your weather app or what have you, which means it has these like added tools or agentic capabilities besides just generating text. But it wasn't using probabilities in the same way these new large language model architectures are, the neural networks are. It was basically taking in what the user said. The user would speak to it. It would transform it into text, transform the audio into text, which itself uses most likely a neural network. So that part is deep learning. Basically, the term deep learning refers to places where a neural network is used. That just defines that. So it is using deep learning to take the audio, transform it into text, and then that text is analyzed based on certain rules. So it's like, if it sees the word weather, it'll then search for where in that sentence is the location. And then it'll say, okay, then search, the weather app based on either where the user is right now or if there is a location present in the text, then use that location, right? And so it's this rule-based system. It's not outputting probabilities. And that's why Siri would often say things like, I'm sorry, I can't help with that. Or like, I don't understand. If you asked it something that wasn't inside its rules, it would have this kind of default response or set of default responses that it would give you if it didn't know what to do. So that's a type of NLP that is text generation, but it is not using a modern LLM architecture. It's not using neural network. It's not using deep learning. It is more of a rules-based AI, natural language processing. So that is AI as well, right? But it's not using a neural network. There's a lot of debate about whether, things like linear models and like linear regression models, very simple data analytics models are AI. I say they are because that was how I was trained at Stanford. And that's like the definition that they use, which is that, any kind of intelligent analysis of data is AI. And then you have buckets under that are like deep learning. So using neural networks on that, which, a basic linear model does not use neural networks. And so that is not deep learning. Anyway, we can get into that next time if you're curious. If you are curious about going into this, let me know. We're getting late in time. Oh, so I guess we actually did cover everything. Okay, that's great. Well, let me know if you want to learn more about, deep learning versus machine learning versus AI versus, computer vision. There's so many different terms, so maybe we'll go over that next time. Let me know in the comments if you want to. And thanks for being here. If you don't know, I'll just let you know that I'm coming out with a course going through all my videos. I have a lot of videos, and I realized that there is a full AI course in those videos. I do have my 10 Days of AI Basics series. I have all 10 days in short form videos, and then I have the first 5 days in long form videos, which are the most crucial parts of actually getting you up and running with like how AI models work. I need to continue that series, like getting the last 5 days out, but the first 5 days should get you, most of the way there. And then you can watch the short videos too for the final 5 days for now. And who knows, maybe by the time you watch this video, there will be more days. So check that out. And I do have, though, a course going through all my videos coming out soon. So if you're interested in learning about that, you can sign up for my newsletter on harpercarrollai.com, or you can just subscribe here. Oh, yeah, speaking of which, if you liked this video, helping me by commenting or liking, subscribing would be so helpful for me and pushing this video out to more people because I want to help everyone learn about AI. It's a really revolutionary technology. And I mean, everyone should know about it. And I want to help everyone develop an intuition for it. And I like talking about it. So I really appreciate all of your comments. I read through them all. I appreciate every single like, every single subscription. And I like to see you guys returning in the comments. It's fun. We're like making a little community. So yeah, it's fun. I'm really glad to have you here. So I hope this video was helpful for you. If you have any questions for the next Q&A or about anything I said already, please leave a comment below and I hope to see you there. So take care, everyone. Until next time. Bye.